So you now see the full screen and me sharing and me switching the slides probably, yeah? So we can start. So if something is not working and you see the slides are not switching, please tell me. So yeah, let's start. So the topic of my presentation is building production-ready AI agents with Strands Agents Framework and Amazon Bedrock Agent Core. I will shortly switch to Ukraine and then back. So дуже радий, що ви мені запропонували виступати. Як ви чуєте, я можу розмовляти українською мовою, але я залишив Україну у 2000 році, 25 років тому, переїхавши до Німеччини, і не дуже часто спілкувався цією мовою, тому я ще не готовий зробити повний доклад тою мовою, якою я можу розмовляти, ви її не бажаєте чути, це зрозуміло, тому я запропонував, щоб ми зробили на англійській мові. Може, через рік щось буду докладувати. Українською. Дуже радий, коли можу допомогти поширювати знання для української ком'юніті. Це дуже важливо для мене. Я вважаю себе українцем. Ви бачите мою ті-шерт з українським флагом. Я завжди, якщо виступаю для української аудиторії, ношу це. So now switch back because I saw even people not speaking Ukraine for sure with some Portuguese name or Spanish name. So now coming back, that's all for the Ukrainian text. But you can ask questions in the Ukrainian language. I can properly read and understand it. So now let's start. Yeah, only several words about me. Yeah, my name is Vadim, and yeah, I live in Germany. And serverless is my passion. AWS Cloud is my passion. Probably Gen AI I was added to this because we are all kind of exploring what does it mean, how our jobs will be changed through that. I'm extensively speaking, but also blogging. So if you have any questions, you can then contact me, add me, and then we can continue our conversation after this. So what will be that agenda? I will cover a bit of AI terminology because I don't know. It's difficult to ask what background do you have because of the limited time. So at least that we are on the same page. And I will be talking about current challenges with AI agents. Then introduce quite a new service, Amazon Bedrock Agent Core, which went live several months ago. I will be shortly introducing simple sample application. We'll be diving into different features of Agent Core, mainly focusing on gateway runtime memory. I will show you observability and will leave identity. This is the security part, which is probably important, very important for Tech Magic. Then probably to you, and we'll provide the slides because the topic is quite broad. So what I will not show you some very sophisticated agent example, like to book the travel and then to book the hotel and the car and the insurance and then roll back something if something is not working. I don't have these use cases at work currently. So my goal is to show you some simple stuff and give you some, how should I say, some framework so that you can explore this service, and then it's up to you to build then something that fits your needs. Okay, so let's start with the AI terminology. So probably everybody knows, but anyway, large language models are very deep learning models that are pre-trained on vast amount of data and excel at processing, understanding, and generating human language. Everybody know what is prompt is simple natural language request submitted to a language model to receive some response back. And there are mainly two types of those prompts. The user prompt, this is the specific request from the user that asking some questions. And there is also system prompt. This is that general instruction given to the AI to define its behavior. For example, you're an expert in this area and please answer in that kind of tone and so on. And if the questions are outside of this specified topic, simply reply that you are not eligible to answer. This is the usage of the system prompt. They will be talking about model context protocol. I will show you examples, but Ilya will be talking in more depth. And it's only important just to understand this is an open standard, an open source framework that allows servers to expose tools or functions that can be invoked by large language models. And these tools enable to interact with external systems, such as databases and so on, because large language models are trained on the mostly publicly available data. And if there is some certain context, and I will show you example about ordering. Yeah, this is our own application, and the LLMs will not be able to answer these questions, and the tools enable just to conduct this just conduct this type of information. LLM and agent is basically something that runs tools in a loop to achieve a goal. Yeah, so they complete tasks using tools, memory and usage. One moment, Leon. Sorry, my son is very emotionally discussing Nintendo game. Um, so agent, we will be writing one with Strands agent as basically use these tools in a loop, and LLM just to provide the response using the information coming from the tools. And sometimes there is not one agent, so there is a workflow. So this is the AI-driven process where many agents make decision. I give you the example of some booking process. One agent may book hotel, another might book the car, and they kind of interact just to do what you ask the agent to do, maybe they purchase the whole chain. And then maybe the human loop in that, yeah, provide you choices and you decide. I will not be touching any agent-to-agent protocol. Yeah, I will be only talking about MCP, but with agent-to-agent, the agent can talk to the agents instead of the tools that the agent export. It's another protocol by Google, but even if the framework supports this, I will not show you any examples of that. You can explore that. So what are the current challenges with the development of AI agents? Probably you read all these papers that, it's a complex undertaking. Many such things don't leave the POC, proof of concept. Yeah, it's easy to build some chat that you run locally, but the enterprise world is really different, and it's different because you need to take into the consideration the whole non-functional requirements like scalability, security, observability, operational concerns. And this is something that just is required, especially if you're in the enterprise world, to put something live. And with that, I will introduce you to the Amazon Bedrock Agent Core service. Once again, it's quite new, and maybe what I'm telling you today will not be the same tomorrow because things are released and changed on the quite a huge pace. But what this service, and this is also the collection of different features that we will look this, is enable you to deploy, operate highly effective agents securely at scale using any framework and any programming language, and mostly any LLM. Yeah, some local ones might not fit, but it's not about only using Amazon Bedrock itself, but you can use OpenAI directly or Anthropic and so on. We will be looking into this. And it helps you to accelerate this, putting these AI agents into production with the scale, reliability, security, which are critical. And what I will be talking about in the end, these agent core services are composable. So you are not required to use them all, and you can even combine some using from this cloud provider and others even from other cloud providers, which is quite unique for how AWS operates. So what we will be looking into, you see, basically, we will start and I will show you my journey, how I got access to these services. And I basically will start with the Agent Core Gateway. I will explain you why. And then we will be looking to runtime, memory, and observability. And I will leave identity up to you for the sake of the time. So now I will introduce some very simple applications. Probably if you know me, you know I like serverless applications, simply. Yeah, that's basically we use it at work, but it's not to talk about this. But you see some very simple application to create orders. Like we have orders API, a bunch of Lambda function with business logic to create order, to store the order in database, get order by ID, update order status, get orders by created date range, like give me all orders for the months, November this year. And I store this in some database. It just doesn't matter here. For that example, it's Aurora DSQL, quite new database. It can be DynamoDB. It doesn't matter. So the question I was asking myself, if I develop this and I block a lot about type of applications, how can I talk to this application using natural language? And the question I was asking prior to releasing Agent Core. And there are options to do that even without Agent Core. I leave it to to explore, but there are a lot of MCP servers provided AWS out of the box. There is one for Amazon SQL database, and you see on the left side, lots of them. Also for DynamoDB, and you can directly talk to the database, which might be a bit scary. By default, you only will be doing like read operations. It's very easy to set up. You clone the database from the GitHub or MCP server, create credentials, more or less provide endpoint, and you can start asking the questions. But it's not a good practice to talk directly to the database. In the software development, that's the same as also here. But it gives you see that you can define, you can specify LLM like Anthropic or Amazon Nova, and you see that the SQL statements will be generated. Sometimes they're not valid, they will be regenerated. It burns a lot of tokens, but basically it works. But the question was, can I access this type of architecture from like kind of through the MCP just by providing some tools back? Like, can I use API gateway or Lambda or directly talk to them without rewriting something, without installing something? And exactly to this time, Agent Core was released, and one of these components was this Agent Core or features Agent Core Gateway. And we start with that, just to see what does it provide to us. So it provides an easy and secure way to build, deploy, and discover, connect tools at scale. With Gateway, developers can convert APIs, including existing API gateway, REST APIs, and Lambda function, and existing services to model context protocol compatible tools. So you basically, this serves as a MCP server. The text in the MCP server, when you can define multiple targets, different APIs or different Lambda functions, and we will be looking to example how to export those tools. And the cool thing is Agent Core supports everything that can be exported as an open API or Smithy. This is AWS own API definition language, or Lambda is a gateway. So it's not necessarily the case that you need to host your API. It can be weather API. So you only need open API specification from that. But of course, Amazon API Gateway supports that. And we can extract open API from that. It also supports agent to agent. I will not be touching that. And there are also, you can deploy your own MCP server and use integrations. So if you go to the Agent Core Gateway, you see this supported targets. And we will already explore in REST API and Lambda IRN. I will leave integrations to you, but basically you see from the integration point of view, you can connect it to the Jira, PagerDuty, Confluence, a lot of pre-built integrations, like just to talk to these services through the MCP tools. But we will be focusing on Open API as a target, and I will be using API Gateway, which is hosted on AWS as this target. And once again, you can use any API which is hosted, or you even don't have access to it outside of AWS. So basically what you need to do is to provide, you see here, Open API schema. You can inline that. I will not show you any infrastructure as code. I will show you only the GUI, how it looks like on the AWS service page, just not to overwhelm you with that infrastructure as a code. Or you can upload this Open API schema to S3 and simply say, okay, I give that the URL to the where is file was uploaded. You see here API or the production JSON. And if you know how Open API schema looks like, there is nothing special and new here. You provide the server. This is the URL. In my case, it will be API Gateway URL, which is unique. I deploy it. And basically, you provide operations that you will export as MCP tools. These are everything below the path. And I will only export. My API supports create order and update order, but I would like only to talk to the read APIs, like get order by ID on the left side. You see that the summary, we need description, we need operation, get order by ID. And on the right side, you see orders by created dates. You see also the parameters in the order by ID, get order by ID. It's ID as a parameter. which is also required parameter. And in the operation orders by created day, we have two parameters, start day and end day. So give the orders between the 1st of November and today is what, 25th of November, start and end day. This is the standard Open API format. There is more. There are response codes that you can define there, but this is basically, you can extract more than the half of it from the Amazon API gateway, from the deployed API, and then add some information because the things are missing, or many servers anyway provide Open API specification. You can even reverse engineer it, even if I will not recommend to do that. And that's it. We provide Open API specification, and then we can simply deploy this this gateway. So once again, we only these two things will be exported as a tool. Nothing else. Only what I can put here, subset of operations that API supports, and everything else to leave out. The most important thing is this gateway resource URL that will be generated. You see here in the red. And you see then the suffix is MCP. What does it mean? There are different MCP protocols, or they support different delivery protocols. There is STDO. If you are doing something locally, it's not the case. There is server sent events, which is deprecated but still supported, but it will have the suffix SSE. And if it's the suffix MCP, it supports the delivery protocol, which is streamable HTTP. So you can stream asynchronously the response through HTTP. And this is what exactly Gateway supports. There are different versions of data. I will leave it out. It's very interesting. It just also develops on the very big pace. So now the question is, how can I talk to this MCP server, which then will expose two tools, get order by ID, get order by created dates. I will introduce the Strands Agent SDK. This is the Python framework, which is developed by AWS itself, which has a nice integration to AWS world. But there are, of course, you can use CrewAI, LangChain, Lang4j. You can even use Spring AI with Java. It just doesn't matter. But I will stick to this because I mostly export this framework. So once again, it's a Python framework. So agents are basically Python application there. And it simply provides certain things, how to easily talk to the agents. It has built-in MCP support, agent-to-agent support. It's model agnostic. It's bind to Python, but it's model agnostic. You can use Amazon Bedrock or directly Anthropic, Light LLM, even local or Llama, Open AI, so whatever you would like. So now let's look how just to talk to this using some LLM. To this application, I populated a lot of orders. These are fake orders with fake items, so that we can get something back. So you see, we import bunch of Python stuff like agents. We will using Bedrock model. The first thing we need to put here this agent core gateway URL, which was generated when we kind of created the agent core gateway. This is /MCP in the end. And this is the run agent method, which is the heart of this application. So first of all, we need the token. This is the identity part, which I will leave out. This is basically JSON web token that you get from the Cognita endpoint, which is OAuth 0. I will leave it to you. Then we define MCP client. We would like to talk to the MCP server, which is exposed by gateway URL. And you see, we create this streamable HTTP transport. This is basically the method to create this client. This token goes there as the BR token for HTTP header. Once again, I don't want to dive into that. And then we can do certain things with that MCP client. With the agent gateway URL, we are talking kind of to our client. And you see there is standard, this is the open standard. So there are standard operations like list tools. And with that, we will receive back these two tools, get order by ID, get order by created date. We can simply print it out that we see we can talk to this. But of course, we need some agent and some LLM just to proceed the response. We'll be asking questions. And then this framework will be looking, do I need to use tools or not? I will show it here. So basically, the simple agent can simply be created with agent, and if you have tools, you can pass the tools. Or you can also additionally define the model. Default model is Bedrock, and I think they will be using Anthropic, but it's up to you to define the actively defined I'm doing here Bedrock model with Amazon Nova. You can set the temperature, you can set the system prompt. This all works. You can add additional tools. Strands agent brings the tools out of the box if you need them. I don't need them here, but there are calculator, there is a HTTP search, they can use search the web. Additionally, for information, there is a file tool, shell, and so on. I don't need it, but in case you can simply add it to the tools list, yeah, which are extracted from the MCP, and then you can pass them not only the tools, but all the model to the agent. It's up to you, but basically you see several lines of code, and then we can use the prompt, yeah, simply so that the agent will ask the questions. So now let's use that prompt. And the prompt is give me information about some existing order. What will be happening here, you see, I'm running this agent, this Python application, first of all, locally. And you see it thinks and says, okay, I will retrieve the information about this order, and I need to use this tool, get order by ID. Yeah, the LLM understood I cannot provide that information. I have access to MCP server, and there are two tools, and get order by ID tools from the description of these tools is exactly what I need to use to provide that information from some external system, which is this API gateway Lambda Aurora application that I showed you, and then it correctly lists you the information about that order. Another prompt, can you list orders created between the 1st of August, 5 a.m. and 5th of August, 3 a.m. And I additionally give the format because it's Java application that the data is stored in certain format. The LLM cannot know this, so I give it as an example. And what you see, the same, it's thinking and says, I don't have access to that information, but there is a tool, get orders by created dates. And I will use that tool, and it provides then 10 orders, which was the correct answer, yeah, by simply just talking to application. And behind there is API gateway and Lambda, which exactly does the search via the database. So LLMs are powerful enough to identify, do they have information, what tools do they have access to, and what tools to use. We don't need to do anything. LLMs are especially powerful one like Anthropic. They can go through this chain of thought and do all the stuff. So pretty powerful. So this is the example that I showed you with the API gateway or Open API. You can talk to Lambdas directly. Yeah, so in my application, I had certain Lambda functions behind the API gateway. I could talk by exporting API gateway targets, but I can also export Lambdas, AWS Lambdas directly as a target. Works basically the same way. You see Lambda IRN, I define the existing Lambda function, which does get order by ID work, talking to the database. In an inline schema, you see I give the tool the name, get order by ID tool. I give the description tool to get the order by ID, and we have required parameter ID. Another Lambda function to do the same for the orders by created date. The same stuff. I have two parameters, basically, end date, and start date and end date, and they are both required. And I have two targets for this gateway. Yeah, two Lambda function. Each is responsible for one tool, basically. Yeah, there will be two exported, basically the same two tools, but not through API gateway, but directly through Lambda. It's a matter of taste. I will prefer to do it by API gateway, so I can exchange even Lambda implementations, and there is certain security provided by API gateway. So it's up to you, and everything else prompts are the same because it's basically the same application. Yeah, once again, here I'm talking directly to Lambda, and previously I talked through API gateway, which then talk to the same Lambda functions. Then it's kind of up to you. Now, of course, we run this application locally and it's not production ready. And we need to dive just into certain other aspects, how to securely run this application. So this is the runtime part, so the agent core runtime. And of course, you can deploy your Python application. Strands agents is Python application, so you simply can use any of these existing options to simply deploy your application. But they are not ideal because agents have certain requirements. And this is what is specifically covered by a runtime. It provides a secure, serverless, and purpose-built hosting environment to deploy and run your agents. And it has benefits. It's once again framework agnostic. You can deploy whatever framework, not only Strands agents. It also more or less model flexibility. It's not very good to pack local model there, but everything that can be accessed via API like Bedrock or Anthropic or Google Gemini or OpenAI, everything works. It supports certain protocols. We will be focusing how to export this, especially for HTTP, but there is also MCP, agent to agent, and so on. Yeah, the cool thing is that runtime supports real-time interactions, but also long-running workloads. Sometimes you just need to wait for the response, and it works up to 8 hours. That's why, for example, it doesn't work for Lambda very well, and maybe just to wait 8 hours and run EC2 server is not the best option either. It provides session isolation, of course. Each user session runs in a dedicated micro VM with isolated CPU, memory, and file system. And it, of course, helps the separation of tenants. And if this VM will go away, then terminate, basically, and everything will be sanitized. That's the security part of it. And if you heard about micro-VM, yes, this is the firecracker, which is used in AWS Lambda, but also in the SQL database, and it fits very well the needs. It was a bit enhanced to support agent, yeah, and the reason is that agent session vary from milliseconds, and then can last into 2 hours, yeah, multi-turn interaction, thousands of tool calls, and so on. My example is simple, but the real world examples are different. The context may vary from 0 to gigabytes. You can pass PDF documents back and forth. And that's important that the firecracker has the flexibility to grow and shrink the CPU and memory out of the box. So if they see there is a much more context passing event, and this VM may be become a bit bigger without you to think even about that. So there are many options now how to deploy this agent to the agent core runtime. You can deploy the code itself. Now there is more or less you deploy the code to S3 Python application, or you can use the container. The option with S3 code works only for Python. Yeah, when you deploy code directly, it doesn't work for Java, something like this. I will be showing you ECR part with a container. And there are also other options there. Yeah, basically the workflow is either it's a zip file of your application or is a Docker image, which is then hosted on Amazon ECR. And so what's important here, this runtime gives you, there are certain options. There is SDK option. I will leave it also to you. And there is an option when we control and create the Docker image. And in Python, you are using fast API and so on, and agent core runtime has only certain requirements. Fast API server, this is the web server framework for handling requests, and we need to kind of provide two endpoints. The first is invocations endpoint. This is the logic of your agent, and it will be the post endpoint. And the ping is for the health check of the application. Yeah, currently, it supports only Docker containers, which are ARM based. So we need Graviton instances, EC2 instances to build this. Yeah, maybe it will change in the future. Let's see, but you can take T4 instance and build the Docker image or something else. And yeah, this is basically the picture. So we only need the most important endpoint is this post endpoint, and let's see how to port that code that we run locally now to be able to be deployed on the runtime. And the code is similar. You provide this gateway URL because we'll be talking to this MCP server. You create this fast API, and then you have this on the right side. This app, and we say, okay, app post / invocations, and this is the method. You see that's asynchronous method that will be invoked when we invoke the agent, and basically it does what I showed you previously. Yeah, we get the prompt from the request, and then we initialize Bedrock model. We get the access token, security part. We connect to the MCP client. Yeah, printing out the tools, and then we talk to the model. And that's basically it. So that's a bit rewritten version that I showed you for the local stuff, which simply provides these two endpoints to be ready to be deployed on the runtime. If you deploy, and then simply, if you deploy this on the runtime, what we see here runtime agent is deployed. We see here there are endpoints. It's always default, but it's associated with the version. So we have here a list of versions. First of all, you deploy the application, you have the first version. If you do it for the first time, then you can update your code and then deploy it once again, and then you will have multiple versions, and you will probably associate the last version, the last deployed version with the endpoint. And each version, in case you're using container, is associated with ECR repository where your Docker image is stored. So if you deploy something to the runtime, then the image Docker image will go to the repository, and then it will be connected. Basically, in case you use deployment without ECR, then will be a connection to S3 bucket, I think. This is more or less how to deploy it. It's not very relevant. You can find it out from the documentation. You see the Docker file on the left side. Below this is the requirements txt with all dependencies, and more or less we build the agent. This is the Docker file, how to build and then start the application in the below CM block. And on the right side, you see Python SDK, how to create this agent runtime. Nothing very specific here. Basically, you first of all upload the Docker image created to the ECR, then provide ECR endpoint here, and then you will get the runtime IRN back. That's more or less it. And then you can go to the runtime UI on the AWS, for example, and provide right there the prompt, what we already saw. Give me information about some existing order. But of course, on the right side, this is the Python code, how to invoke this agent which runs on the agent core runtime. You need agent core client for this, and then you do invoke agent runtime by providing this runtime IRN that's generated when you deploy or update it. You have all this this file, and then you provide payload, which is your prompt. And then as it asynchronous, you simply stream back the response. So basically the agent is now running on the runtime. So, and we can do this stuff. So this was the runtime part of the time. Okay, I have 15 minutes, something like that. Let's dive to at least to the memory concept. So by default, the agent are stateless. So they don't remember any previous conversations. And sometimes it's not okay because you can stop talking to the agent on the evening, and you would like to restart something, and you don't want to retrieve the same information, or you would like to summarize something like what is the total value of orders that I was asking you today. With that, you need to provide some memory capabilities. So the Strands agents offers anyway two built-in session managers. So there is file session manager and S3 session manager, so you can store the conversation on the local file system on S3 buckets, and it provides you kind of a bit of memory flair. But there is also the feature of agent core memory itself. So you don't store in S3, but use more professional tools for that. And basically, agent core memory has two flavors: short-term memory, which stores the raw conversation, so exactly prompts and answers, how they are, and there is a long-term memory, which I will not cover. Please look into that, but it can store the preferences, summaries, semantic facts. So this is more RAG-based system. Once again, short-term memory captures the raw interactions, and the question is, we can save it up to 1 year. We define for each memory how we would like to do that. So the thing is now how to do this. So first of all, we need to create memory. This is separate stuff. So we simply create the memory. Say strategies is empty, which means this is short-term memory. If you provide the strategies, it will be long-term one. We say event expiry days. We will store it for 7 days. And then we will get the memory ID after creating the memory. So the question is how to use that. This is how it looks like. You see here on the left side, there's a memory. We have created now short-term memory for 7 days. Now, how to use that, especially with the Strands. I don't know how it works with other frameworks, but Strands agent provides the concept of hooks, and especially hook event lifecycle. So there are different events that we can hook into, and there is here the more or less a description of all of them. And what we will be using is, for example, agent initialized event and message edit event. So in case we initialize the agent, we can retrieve some things stored in memory. And if messages add event, we can store, because it's more or less the conversation. So the thing is how to do that. First of all, we need to write some hook. Yeah, we will call it short-term memory hook. And you see, okay, I'm hanging a bit. Okay, I will come back. So you see this is short-term memory hook. We derive it from the hook provider, which comes from the agent core memory. And we defined in the register method two hooks. Message edit event, and there is a method on message edit, and agent initialized event where the function agent on agent initialized will be invoked. So how it works? Basically, if we add the message, once again, we would like to store that conversation, the raw conversation, in memory. And this is memory client create event, which is memory event. The name is a bit, I would prefer create memory event. Instead, we have this memory ID, we initialize that. There is actor and session ID. I will be talking briefly about this. And with that, we store the conversation. Yeah, so the question about the order and then the response, for example, will be stored. And if the agent is initialized, we can retrieve portion of the from the memory, so that it becomes part of the conversation. So you see here, we load the last 5 conversations from the memory by using this memory client get last k turns. Provide once again memory, action, and session, and number of conversation. You need to tweak that because, yeah, the more messages, the more it will cost you, and you need to think what's the right value. And you see below, we add that to the system prompt. So this will become part of the context. And with that, of course, you need to be careful because it burn the tokens, because the system prompt will become bigger. So the more you retrieve, the worse it will be. So, but it gives you kind of the feeling how to deal with that. The question is how to use those tools, this short-term memory. So first of all, once again, we need to define actor and session ID. I personally use session ID always static. Actor, you need to think, do you have different actors? For example, you can have one actor only asking about orders, and some other user in the user actor asking about user statistics. For that, you might probably assign him however you would like another actor ID, so that the entries will be separated. I have it here statically, but the real example will be probably having at least actor ID dynamically. I initialize memory client with the memory ID that I created. And this is how I can provide the hook. If I instantiate the agent, I have the possibility to provide the hooks and also the state. And with the state, I provide actor and session ID, and the hooks, I provide this short-term memory hook provider that I implemented one slide below. And with that, the agent will be able just to hook into these events, to retrieve something from short-term memory, and then to store the raw conversation also in the memory. And with that, what you can do is you can start, for example, now, hi, my name is Vadim. Today is sunny weather. Give me information about some order. You will get the response. Then you ask the prompt, give me information about another order. And then you can ask, yeah, tell me what my name is in case I've forgotten what was the weather. And then it can be retrieved from the memory, and you see in the answer that information is considered. Of course, you can ask the information later, give me information about the same order that you asked below, and then the LLM will not ask the tool anymore. It will find this information in the system prompt. Yeah, and you can ask to summarize what's the total value of orders that I was asking you today, and they will return, yeah, from turns K the information, but you need to be careful, yeah, because there's maybe something missing. It will be different answers if you say get the last 5 or last 6 events. Yeah, it's completely different stuff. Okay, long-term memory, I will leave to you. The observability part, I would like to cover this, and then observability, everybody knows what is that, and it's crucial. We need to have the visibility about all that stuff. And the good thing is that Agent Core emits telemetry data in standardized open telemetry format, yeah, which enables us to do the search. And what's important here is basically what I would like to show you. Yeah, CloudWatch, we need AWS distro for open telemetry to do this stuff. Yeah, and Adot is a secure production ready AWS supported distribution of open telemetry, which is the part of the cloud native foundation. Yeah, so the question is how we can emit those metrics in the Strands agent. It's really easy. On the right side, you see we add the dependency to AWS open telemetry distro. And on the left side, we see that we start CMD command OpenTelemetry instrument. And with that, this OpenTelemetry will instrument the code by default. We don't need to do anything. We can have custom metrics. It's another topic. But by default, because it's AWS distribution, it's connected to AWS services, and that the metrics will be pushed for you. So this is what I would like to show you by directly on the console, that you see how it looks like. Okay, that will not work because I need to stop the presentation first. And now I can, yeah, now you should see at least the browser. This is how all the things work. So the important thing is you need to enable tracing everywhere. Here for runtime, you see there is logging part that you have logs, but everywhere you need to enable tracing. The same is for gateway. Yeah, I have this gateway that I showed you, the same stuff. I need to enable, yeah, provide logging, and I need to enable tracing. It's loading, but yeah, you see it's enabled. The same is for memory and all that stuff. This is, I think that's the short-term memory. So yeah, the same stuff. Tracing is enabled, logging is enabled. Otherwise, you will not get all the metrics. The thing is, AWS, you will expect at least metrics or at least traces to be in the X-ray. It's not the case. For GenAI stuff, AWS provided GenAI observability in the CloudWatch. This is extra panel. So if you go here to the model invocation, you can look. I did some examples before the talk. It's not too much interesting. There should be the data. It's not loading. Now it's loading. So you can see the model ID or model IDs that you use, invocation, latency, by models, throttle, so on. But there is this Bedrock agent core observability stuff that you will see all the metric traces for the agents, but also specifically for memory, gateways, identity we will not cover. So you see here more or less, you can select the runtime, and then you see the overview, you see the sessions. I ran here some sessions, and with the sessions there are associated traces that you normally will have into the in the X-ray, and now they are loaded, and now you can go basically click on some trace, and you will see lots of information that you are used to from especially from X-ray. I like this trajectory view. You see everything, the whole workflow basically. Yeah, you see, this is the Cognito stuff to get authentication token. Then I talk to the API gateway, agent core gateway, initialized it. Then I listed the tools. Yeah, then I listed the events. This is the part of memory to list events. And then I even created event with a memory. Then there's agentic loop to chat with LM. Yeah, you can, I think, even see what tools have been used by. Yeah, so there is information also about the agent core tool that was used, and so on. And then you can go here to the spans and see more or less what happened and what metadata have been used. So if you select here something, I don't know, agent core initialized, so you will then see all the things, or you can go to the trees view. and simply select this event. There will be the same chain as above. You see how much time did it take. You can go to the metadata and see what information was extracted and so on. So this basically here, this is list tools, this is agent core, this is list events from the memory. So very sophisticated, and it was hugely improved. But once again, it's important that you activate observability everywhere, because otherwise you will have something like post event. And if you don't have traces for agent core gateway enabled, you will not have that here. So there will be simply empty space and you don't know what exactly happens. And once again, with tree and timeline, what you can do is more or less to have the latency. In case you have an error, you will be some red stuff here. So you will see, okay, I ran into the error for whatever reason. For example, the payload was too big for the memory. It happens, there are some restrictions. Then you will be notified. Okay, I will go to the presentation. I will probably need only several minutes to wrap up. Identity will be left into you, and pricing also. So once again, if I give yeah, pricing is basically serverless one. So consumption, the only one exception is long-term memory because it's persistent storage. So they will be also charge you for storage. Yeah. So what we talked about is this more or less runtime gateway, agent core memory, observability. There is identity for security of the zero or IAM. Please check it out. There is browser and code interpreter. I haven't touched it. The most important message is the services are composable. So you can use agent core gateway to expose APIs MCP server, but you can host the agent whenever you want on other cloud provider and talk to this gateway as exposed MCP server. It works. Yeah, the same stuff, you can deploy your agent on the runtime, but expose the metrics to another hotel provider like Datadog. It also works. You are not required to use CloudWatch general observability. And so on. For identity part, you can generate this Auth0 JSON web token through the Cogito or through Keycloak. Yeah, any other compatible provider, it works. So the services are composable. And this is the thing that I haven't seen on AWS side. Since they wanted to lock you in, but now they give you a lot of flexibility. I post a lot of blog posts where I dove deeper into that because this talk deserves probably 2 hours only for what's already released, and it will be more for sure with the time. I also released the blog post how to use Spring AI instead of Java-based framework, instead of agents core Strands agent. There are certain challenges with observability because Strands agent is from AWS. It's connected to CloudWatch nicely. There is a lot more work to do on other frameworks and on other programming languages, but once again, nothing prevents you from using other programming languages. And that's basically it. There is some resources how to write the agents that are really nice with domain engineering, DDD in mind. So maybe that you can just look into that. It involves some nice programming paradigms and not this vibe coding stuff that I personally don't like, but it's another topic. And that's basically it. I have at least 8 minutes or even more, depending what Solomia will allow me to do or not. And I will then switch. Thank you very much for listening. I know it was quick and I saw that several people left, but many stayed. So I hope it was at least informative enough for you so that you can now know at least how to start, what does the framework can, or the service can do and what not. And I will now switch to the board and share this board and see what questions do we have, because there are even more people than registered, which is nice, always nice. So I see the first question. I should read it, or there's so big questions that, but let's see. Need to build
it's gonna be nice if you read it and then give the answer.
Oh, there are 4 questions. I personally, if I will ask it, will probably take 10 minutes, and there are certain advices. I will. I mean, these are, I think, your personal challenges. Um, I don't know if it's appropriate now to because this involves some certain solutions. Maybe I'll start with the second one because the third one is the first one is huge. So from Dmitro, Vadim, why have you decided on this particular theme and stack on technologies for your presentation? Based on recent GI, it's probably not the ready for corporate workloads. Um, so there is nothing else on AWS to really run that. So you can use EC2, but or Kubernetes cluster, but they are not ready. So yes, it's a new service anyway. But what I see, it's and I know what an effort it was on AWS side. It's one of the examples that AWS did not release proof of concept or first iteration. What they already give you is a huge one, yeah. And I don't see anything comparable on AWS to run the agentic application. At least agents, you can use the Bedrock LLM and talk to LLM itself. If it's capable to answer, then it's fine. But if you need something like really agents, tools, agent to agent stuff, then uh, you need certain building blocks like this. I don't know what other cloud providers offer. I know OpenAPI as MCP server is standard offering. Azure is also offering that. It's, by the way, not very difficult to implement. So this is a standard stuff, but just to run that on the runtime, which is secure and which scales, and this agent core runtime scales similar to Lambda with the workloads. So I personally think you can try it out. Yeah? I don't know what are your special requirements. You've also then another question. You've also mentioned IAC approach. So how well Terraform and alternatives cover currently availability? So until GA there was no infrastructure as a code support. So only SDK. But now they cover cloud formation and CDK as far as I know. So no Terraform. That, or at least you need to check. But I think there is a requirement that if the service goes GA, at least cloud formation support should be there, and SDK also is supported. Why does AWS use their own way to connect to MCP using OpenAPI and Lambda? Why can't we connect to external MCP server like Cursor, Copilot, etc.? Why you can't connect to the tools? Yeah, so you can more or less provide. If those tools give you some can be exposed as MCP servers, you can also connect to other MCP services. This is this integration part. Yeah, you can deploy your own MCP server, so you can connect to the MCP servers. So it basically works. From Vitali, why do you have worked with this 3 vector store? How much slow is that in open source? It's unrelated question to be honest to this presentation. I have only worked with S3 vector store, but only for my private blog post, so I cannot compare to open source. And in this type of application, I don't store anything on S3 vector because I don't use embeddings here. Yeah, so S3 store vector store is just to store like embeddings and then search for that. What about hallucination with the context from previous interactions with agents? Might be the case. The certain problems with hallucinations, these are general problems with LLMs. That might be the case. There might be also the case if you have API which provides you very many tools. I have only showed you 2 can have APIs which exposes 20 tools, and it might be the case that LLM cannot decide what to use. That's why you need to carefully see what to expose via OpenAPI to have control about that. Yeah. Otherwise, it's always like if you go shopping and have only 2 things to choose from, then you choose. If you have 20, you're probably stuck. It's the same with LLM. How good is CloudWatch for observing what's happening while using this stack? I have no experience with the stack, but based on my experience. So that's a fair question. Many people argue that CloudWatch for observability might be expensive, especially for injection purposes. And there are other tools that are more capable, like Datadog might be. There is now Dev0 and so on. So it's up to you to explore that. What I see that, of course, the metrics are completely there. but it's not only about the metrics. You would like to search for certain patterns in case you have errors, then you would like to attach something like PagerDuty or something else to notify you. So it's of course not only about capturing the metrics, but also finding out quickly if something is wrong, and in the best case notify you. So this is a broad question, but I'm personally pretty happy that the hotel support is right out of the box there, at least. Yeah, and it gives you the possibility to use something else. So simply explore, but I see it's not half done job. It's okay, and it's really improving. So I did the first shot of this presentation 2 months ago, and then 2 weeks ago looked into the CloudWatch GenAI observability console, and they added a lot. They have changed a lot. So it will improve, but this is a fair question. If you might go to for some open source solution, or sorry, not open source, third party solution, but also compare the pricing. Yeah, so all those solutions are not cheap at all. Yeah, I am now thinking, can I return to the first question, because this is not really relevant to my presentation as far as I know. Uh, because that somebody asked for their personal use case, and this is something it's not even so relevant to my presentation as far as I see. So maybe we can take it offline or
But thank
and
you.
discuss
It's a
there.
great idea. You could stay in this board and leave your writing answer for the first question. And please notice that in Zoom chat we have one question. You can answer. You can write your answer later. And we're gonna move for the next speaker. Ilya, please share the screen and let's begin.
Hello guys, my name is Ilya. I'm happy to present to such a great audience. My topic is MCP protocol and how to build a secure AI agent on AWS using all the MCP features and all the benefits this protocol provides to us. So I will start with a small intro. So I'm currently working at a biotech AI startup based in San Francisco. And also, I'm really active AI community member in this area. So AI developing really fast. And if you check calendar for San Francisco Bay Area, you can see like 50 events, like 20 hackathons each week. So it's really moves really fast, and people exchange with information, knowledge, startups raise like millions of dollars. So it's really intense and dynamic environment for this industry overall and for technology. So, and I'm really happy to be here and being able to exchange with like fresh minds about new trends. And also, there is the best startup loft, GenAI in San Francisco downtown. This is a place when a lot of tech talks happens and a lot of people gather, and also it's like a big hub to exchange knowledge. In the past, I used to work with Global Logic, Customer Times, and Blockchain Lab. So it's my fifth company I work with. And here is some my contact information. Happy to chat after presentation on LinkedIn or have some email conversation. Talking about hackathons, last year I won first place on AWS Bedrock uh, hackathon organized by AWS, and it was really simple idea. So I created a culinary assistant. It's simple idea, but it used all major AWS Bedrock components at that moment. So we had the knowledge base with all recipes. Also, we used AWS Bedrock for LLM access. So image generation and like text conversation was used from AWS Bedrock. And whole idea, you just pick ingredients which you have, and then the system analyze ingredients which you have, check the knowledge base, and return some recipe which may fit for you. And this recipe may not exist in the past. So it may be some unique recipe if you exclude some ingredients or you have some allergens. And also image generation was used. So with this project, I won first place. Also, I did second place on digital government tech hackathon, and also two nomination on Gen AI hackathon as well. For this hackathon, it was a legal assistant AI agent. Basically, it was knowledge base, LLMs, and this legal assistant helped to craft some legal documents and review the documents. For AI engineering evolution, so it started just from prompt engineering. So we had some text-based prompts, some menu optimization, and really limited context window. Then some RAG system was introduced, and multimodal inputs, structured context injection. So basically, the context become bigger. So you can create some knowledge bases, some vector storage, and like basically, yeah, this is what was it was huge movement because you have bigger context window and your agent can provide more accurate response. And currently we are on a MCP era, I would say, because we also add in some complex workflows to our agents. We have already some standardized protocols, and AI agents become more interactive, so they can communicate with each other. They have some protocols, each of them follow. So it really simplifies the way how can we build systems. So what is basically MCP, and what is the problem? What do we need this protocol in the first place? So as we saw for past like 2 years, AI is really a powerful tool. So initially it was just like summarization, making some questions about some context of the internet or asking question about some document. But AI agent was like really isolated. If you remember ChatGPT, like in early days, it has some snapshot of the internet information, and it didn't even have the access to like use browser or just check some API endpoints to gather new data. But now it has this functionality like browser use, but the problem was the AI agent was really isolated and in all terms, like context window, information, and tools they can use. But MCP is really protocol which solves a lot of questions and problems with connecting AI to a real life system, to external system, and do it securely. So that's why we need this protocol just to connect the AI application to external system, like in one world. So in one hand, we have external system like databases, development tools, productivity tools. We see Slack is mentioned here, Sentry, Postgres, and Sentry does have their own official MCP server which they maintain, so we can use it. And on the other hand, we have a chat interface. It can be Cloud Desktop, or you can use some IDE to work with MCP. And also you can create your own AI application which can talk with MCP servers. So basically MCP is kind of type C for AI application. It's protocol which everyone follows and makes development easier. So this slide shows a connection architecture, like one to one. So we have one client, we have one server, they have some connection, they communicate, and maintain this connection. Core three functionalities: it's tool, resources, and prompts. When we talk about tools, they just enable tools enable model to perform actions with typed input and output, but model decide when to execute them and based on the context. So basically, tool is controlled by model. Some examples, what we can do, like search flight, send message, create calendar event. And basically, LLM calls tool and pass some parameters and waiting for some response. Second part is resource. So resource is managed by application. Example, retrieve a document, access knowledge base, read calendar. So it's basically the layer which provide us access to the resources. As I mentioned, it can be documents, databases. So we need to implement it on our own, this programmatically. And prompts, just it's controlled by user. User can make these prompts. It's basically reusable templates that combines tools, resources for common workflows. So basically, it's pre-built template which we configured once, and it describe how to work with tools and resources. It's two more layers: data and transport. So data layer defines how messages are structured and exchanged. So JSON RPC is used, and what it handles basically: a data layer, connection, lifecycle, initialization, negotiation, termination, service capabilities, just to describe which tools we have, what resources, client interaction, user input, login, and real-time updates. It's notification and progress tracking. For transport layer, we have two main types. It's HTTP transport. It's for remote MCP servers. Basically, it's network-based communication. You have remote MCP servers, and more likely, if you deploy your MCP to AWS cloud and you want to use it in local machine, you will use this type of communication. And also you have a local local type. So it's direct process to process communication, and it's really good for local development because you don't have any network like delay, and it's really easy to integrate. I will show some demo later for both of them, for both types. So where you can run MCP locally and remotely. For a local environment, you can directly control all the resources and configuration. It's perfect for local development, testing, and debugging. And also you can work without internet at all. You can keep your sensitive information and minimal network overhead. For remote MCP, you can share it like with your team, these MCP servers, so you can collaborate. You can offload your computer or your physical server to cloud. Basically, the main feature is easier to manage, scale, and basically you need less heavy like equipment. You do not need to have a really powerful computer. You can just use cloud provider, and that's it. And one more thing about protocols, so there is some agent-to-agent protocol. What is the key feature? Basically, you allow agent to talk with each other, share their capabilities, resources, and they can cooperate. And the idea is just to create one agent which does one thing but perfect, and then allow create multiple agent, and they can communicate with each other, make chain of requests, and solve the idea, solve the problem. So this is the idea. And here is some example of agent-to-agent communication. For example, we have a HR agent, and we have an employee database agent. and they communicate with each other, and employee database agent have access to some external resources like AWS Bedrock, maybe some database, and then these resources can be used to return response to initial agent. Basically, yeah, so agent to agent, like multiple agents, they communicate to each other, and they can decide whom to talk and in which context. And here is some diagram. We can maybe pause here for maybe 1 minute and take a look. But this diagram illustrate agent-to-agent communication, which I mentioned previously. So we have like user, we have some API endpoint. So user talks to HR agent with MCP client. Then this HR agent make query to employee information agent, which at the same time make modified request to LLM and request some data. Then this data will be processed by LLM, and processed answer will be returned to initial agent. And this communication can happen like in loop, so agent can talk with each other like a real people on demand, based on context, based on the triggers. So this is a whole idea. Yeah, and why it's so good for specific use case? So you can create specialized agent for different domains. They communicate through some standardized protocol, MCP. It's pretty scalable, and you can build modular, complex workflows. And here is some example how bad actors may use MCP as well. There was recently some uh, like publication from Anthropic. So some bad actor used MCP server for a pen test purpose. Basically, MCP was used for hacking. So this bad actor wrapped all the security tools with MCP. So it was some scanning tools, exploitation tools. So security pen testing has multiple stages. In some stages, you just understand the infrastructure, all the libraries used, all the components, all the like building blocks. As you see, like it was started by gathering data. So lots of tools was used to scan infrastructure, receive some data, have some code analysis. Yeah. Another step was to try to exploit some security issues. And final stage was like basically exploited. Yeah. In this diagram, we see the human in the loop was here, but also this part can be changed by like another agent. So whole this diagram can be implemented into reality without even human in the loop. But human was used to yeah, to to make performance better, because maybe human was really cybersecurity aware. Yeah. Here I want to review some AWS MCP servers which are present. So there is some repository with AWS MCPs. So I checked it recently, and it's really huge list. Do you see the screen with GitHub? So I was really surprised by amount of tools we have here. For example, we have some basic MCP server for API, for knowledge base. For API MCP server, you can basically ask AWS to perform some actions on AWS, basically delete some bucket, create some resources. So basically it's a wrapper over AWS API itself. For knowledge base, the idea is you can, because AWS have documentation, they really maintain it. And if you have question about, if you have AWS related question and you trust documentation fully, you can ask your client, it can be Cursor or another IDE or another MCP client, to use AWS knowledge base as a source of truth, not to be disturbed by some data from internet which can be not verified. And they have really huge list of another MCP servers for RDS instance as well as was mentioned before. So I left this URL in presentation. It will be shared later. Yeah. What else? Yeah, we can check this. Basically, we can see the source code of server, MCP server. For example, this one. So as we see, we have some instructions here. And also we have a tool wrapper. So we have this decorator. And here we have one tool, list users. And here we see some implementation. So I will share this. Yeah, also we have another tools. So I will share these URLs after the meeting. And yeah, I wanted to make some small demo just to build our own MCP server. It will be really simplified. And basically, I checked previous implementations. They mostly used fast MCP as a library for MCP. So what basically this MCP server does, it's one tool. The tool has access to AWS, and it can return a list of all buckets we have. So basically, it's one small tool, and I have it opened here. This is a cursor. This is a code implementation. Also, this MCP server is connected to cursor. You see it's here. It only has one tool, which is listed here. And here is MCP JSON. This is the configuration file when this tool was added. Basically, here is the configuration to edit. And I will have some small demo here just to ask some question. And as you see, there was some thought process, and cursor saw that there is some MCP server which he can use to perform this action. And he suggests me to allow this action to execute this. And now we see response. So basically, two buckets were listed. Here is basically at the best part, I do have two buckets for this specific demo. And MCP server was able to connect to AWS, make some bot3 query, and return this response. And also, I have another query for demo. So this MCP is local. It's running locally. And also we have remote MCP. And I will make some question about S3 bucket security. I see. For some reason, it decided not to use the tool. But okay, maybe. Yeah, basically, but ideally it should use this one. It should have used the knowledge one. Because this one is related to documentation, and this remote MCP managed by AWS to run this MCP server, to connect client to this MCP, you do not need any credentials, you can just use it. But for another ones, for example, for this one, for example, you do need some tokens, some credentials, because it really interact with your AWS system. Yeah. Basically, here is a screenshot of the demo. And talking about security. So MCP clients are really cool, but you should trust them as an alien, because they basically need to use principle of least privileges, do not share with some root access, and they should be really focused on specific task to do, and do not grant them really like root permissions, because if you treat it not the right way, it can be really a security issue. It's for both when you use your own MCP or when you use external ones. So for external ones, you may have some data breach, or basically if some MCP server was compromised, you can basically have some remote code execution issue with your own system, or if you maintain some public MCP, you can also have some security issues if you do not limit the authorization, you do not sanitize all the input, manage credentials. And there is some best practice guide from OWASP. So here is URL, you can check it after the presentation. Talking about deploying. So we had previous talk about specific service which can be used for deploying. But if we talk about simplifying everything, so Lambda can work, ECS container can work, EC2 instance can work. Basically, managed Kubernetes service also can work. So you can make your own architecture decision based on your use case, and it depends on is it enterprise deployment, or you have building some proof of concept, or maybe you have some price concerns, you don't want to pay for some extra services. And in this slide, I just wanted to highlight that all these MCP servers for which AWS maintain, they do have this container imaged on public. Basically, it's available publicly on ECR, and you can use it. Here is some diagram for deploying MCPs on AWS. On this diagram, we mostly see AWS Fargate, Lambda, application load balancer, some CloudFront stuff. So this is like really simplified, not really simplified, but it's really like a MVP to build it like securely and without like additional effort. So I can pause here for maybe 1 minute just to take a look. So we do have some web application firewall layer here, some certificate manager, container registry. But the deployment part looks really straightforward. How to run MCP client. So basically, the easiest way just to attach it to your IDE if you want to use it as an end user. And I already mentioned how you can do it. For a cursor app, I can also make some small demo. How easy is it to add new MCP server and use it like in your development or during an interaction with your AWS system. So basically, if you check this GitHub repo, you can just click install cursor. There will be some configuration passed to cursor, and then you can just review if everything looks good to you and click install. Some errors here. Okay, we can check other one. Yeah, this one looks good. So AWS diagram MCP server, we see some tools it has, like generate diagram, list some icons, examples, and I should see also this MCP server here. Yeah, so it was exported. You see the command executes, some information. Yeah, so it's pretty straightforward, and then you can just use this chat window, ask some question, and based on the context, the Claude will decide. Not Claude, the cursor will decide which tool to use. What else can I show? Yeah, there is also a Claude desktop app. You can use some Visual Studio extension. Kiro is AWS managed solution, also AWS QCLI. Yeah, Amazon Q you can use. Here a screenshot. Here basically I showed the previous demo, which worked fine. So I asked what is the best practice for S3 bucket security, and in this use case, Cursor decided to use MCP search documentation tool from AWS, and the response was provided to me. And here is in this here we see like which MCP servers was enabled by the moment when I made this query. Yeah, some resources I want to share. So basically, this is a good one. It's just a GitHub repo for MCP protocol by itself. Also, they have a section with servers where you can find all officially maintained servers which you can use. AWS related MCPs, which I showed in the past. Some available images of MCP, and OWASP. It's a foundation which make security awareness related publications, and so they have lots of publications related to security, and you can check MCP server related one. They also have a top rank of LLM vulnerabilities you should be aware of. So I highly recommend to check this resource. And I'm ready for questions. Yeah, so I'm ready for questions. We have a lot of time, and maybe I can also come back to some slides if needed. I see a lot of questions. Так. What metrics do you use to evaluate the business value of the agent? What criteria do you use to evaluate its accuracy and stability in production? Business value is really a wide topic. For some companies just use AI agent just to improve something. For example, like tech support. So it can be just some guidance for the person. So there are some companies which provide tech support, and they have real human who physically check the question, respond to this question. They may have some knowledge base. They may have some automation already created even without AI. And for this business, you can use AI like to make it like faster, to have more personalized response based on the data you have about specific customer or about specific user. So this can be the metric, just how fast the support engineer can make this response. Also, we see another type of companies like AI first companies, which try to limit amount of humans they have at all. They want to build all these automation workflows, and the business value, it can be just basically revenue, amount of customers, and amount of revenue divided by amount of people they have. Okay, what can you say to MCP alternatives? Maybe there are certain scenarios where something else will be more preferable. Mm. So it really depends on your architecture specifically. So if you need some simple summary of some data, you do not require MCP. MCP, it's look more like a wrapper over some tool, and you can use it for 100% of its capabilities when you have some like agent-to-agent communication, when you allow to LLM to decide which tool to use. But if your workflow is really standardized and you can expect what is the input, what is output, so you may not need like MCP. But MCP is really a good way to make. Basically, it's wrapper, and you can make lots of stuff more modular. So this is my answer. How well is it its current documentation? Example in different languages present. So this is really a good question. From my knowledge, for my experience just using LLMs, so I attended some hackathon, and these people presented us with JavaScript library and Python library. And initially the idea was to use JavaScript because my second teammate was full stack engineer, and we tried to use LLM to speed up our development. But then I find out that LLM works not so good for JavaScript library at the time. So it was faster to us just to switch to Python completely. But based on different language, documentation may be different. But yeah. But I feel like most of them should be covered with SDK. Okay, when agent executes a chain of actions through different MCP tools, how tracing is implemented? Can we see logs? Which tool had some issues? And how can we differentiate the MCP issue with hallucination of the model? So I'm more than sure the Vadim have answer for this question about tracing tools, because I didn't use any native tools of AWS for tracing yet. For my friends' experience, who are startup founders, sometimes people use core AWS services, but for tracing, for example, they can use some external service and make this integration. So there are a lot of startups within this space, even within tracing. But it's really a good question. Please share a link to that pen test scenario you have. Was it legal for in-house or hacking? So basically, it was released by Anthropic, and what they say, they saw some suspicious activity based. uh, can you hear me? I don't have a chat. Let me check the chat if you can hear me well.
We hear you well. Yes, we hear you well.
Yeah. So for Anthropic one, yes. So here is the original posting about Anthropic one. Basically, they saw that some bad actor, maybe from China, used Claude to create orchestration for cybersecurity attacks. So they had a lot of scanning tools, search tools, exploitation tools. They wrapped it everything into MCP tool, and they used Anthropic as a cloud as a foundational model to perform this cyber attack. And why it was not so easy to detect by Anthropic side, because they all this pen test and all this cybersecurity workflow was split into smaller tasks. For example, scan specific IP address, or just scan this like repo for to do some static code analysis. So the prompt was not like hack the system. It was really small tasks which looked really not dangerous, I would say. And they, I'm definitely sure they did some uh, prompt engineering. For example, they may say, "I own this infrastructure. Please perform some safe scanning." So this was the publication. And also there was recent publication from ChatGPT. From OpenAI, they released some cybersecurity researcher. For their use case, they use some sandbox environment. They use static code analysis. So basically, they scan the code base, then identify if some security issue may be present, and then they use sandbox environment to try to exploit it, and then they write reports. But it was just some announcement that they only have it in some private for private demo for private usage. How well MCP is for in terms of observability? How easy is it to troubleshoot issues? So I had this really simple MCP server which I did run locally. It's it was in Python, and I did have some errors. It did not work from the first time, even this is like for 15 lines. But I would say it, it's possible if you if you troubleshoot specific MCP server, it should be possible. It shouldn't be too difficult. Uh, how mature, in your opinion, how mature is MCP on AWS infra? My personal opinion, so AWS is really powerful ecosystem. They already have like all you need, all the building blocks, and you can use their own services. So they have AWS Bedrock. They have lots of other components. They have some core compute network components. So I would say it's really depends on your own implementation. So you have all components in place. They may have more user-friendly services in the future, but you already can build MCP servers on build and deploy, and you have everything you need and at this moment. Yeah, looks like I covered most of the questions, so we saved a lot of time.